Alright, today we're solving quadratic equations by graphing. So we're going to use what we learned about how to graph a quadratic equation, a parabola, and use that to find a solution for an equation. For example, I want to solve this. Now we learned how to solve it algebraically by factoring last chapter. Okay, we can move the 3 to the other side and factor and use our zero product property. We learned that. But now we're going to add in some graphing procedures. So our first step is the same as it was when we were solving algebraically. We're going to move the 3 to the other side so that we have our equation equal to 0. Then what we're going to do is we're going to graph it as if it were y equals x squared minus 2x minus 3, and we're just going to find when y is 0. Because when y is 0 on this graph, we have our x values that would fit this equation up here. Right? If x makes our y value in this equation equal to 0, then that's a solution for this equation. If x makes our y values here 0, then those are x values that will make this equation true. Make sense? Make 0 come out. So we're going to graph this equation right here, y equals x squared minus 2x minus 3. So this will be good review for how to graph quadratic. So the first step is to find our axis of symmetry. So how do we find our axis of symmetry? What does x have to equal?
Negative b over a
2a. Okay, so what's b in this case?
2.
Negative 2. What's a? 1. So what do we get when we simplify that?
1.
X equals 1. That's our axis of symmetry. Everybody okay with that? So we can draw our axis of symmetry. What's our next step after we found our axis of symmetry? We got to find our vertex. And how do we find our vertex? Plug in that axis value, that x value for x. And what do we get?
Negative 5.
Let's see, we got 1, minus 2, minus 3. What does that equal?
Negative 4.
Negative 4. There's our vertex. So far, so good?
How did you find the 1?
The 1 we find by saying x equals negative b. This is our b, the coefficient of x, over 2a. A is the coefficient of x squared.
Okay.
So when we plug that in and simplify, we get positive 1. Yep. All right. Now, since a is 1, we could follow our pattern of 1, 3, 5, 7, 9, right? Whoa, wrong button. So that means we go over 1, up 1, over 1, up 3, over 1, up 5, and so on. Everybody good?
Through the process we used in 10.1.
Yes, same thing we did in 10.1. So remember that we said our solutions are when y equals 0, right? What are the x values when y equals 0? Negative 1 and 3. We have the point negative 1, 0 here, and the point 3, 0 here. Because remember, when y equals 0, we're on our x-axis. So we're just finding where it crosses the x-axis. Okay? Those are our solutions. So our solutions are x equals 3 and x equals negative 1. Now what we can do to check is we can go back to our original equation and plug those in. Does 3 squared minus 2 times 3 equal 3? What's 3 squared? 9. What's negative 2 times 3? Negative 6. When we subtract, do we get 3? Yes. We can check negative 1. Negative 1 squared minus 2 times negative 1. What's negative 1 squared? 1. What's negative 2 times negative 1?
2.
Does 1 plus 2 equal 3?
Yes.
I hope so. Okay, so both of those numbers work. That's what identifies them as our solution. So we graph our parabola, we find where it crosses the y-axis, and those are our solutions. Everybody good so far? Let's try another example. So, what was our first step?
Subtract 1.
Yep, get everything on one side. Okay. And then we change it to y equals, and we graph it. Right? So let's start by finding our axis of symmetry, which is x equals what? Negative b over 2 times a. What's b in this case? 2. What's a? Negative 1. What does that equal? What's negative 2 divided by 2 times negative 1? 1. So our axis of symmetry is x equals 1.
Again.
How do we find our vertex?
Plug it in.
Plug it in. What do we get? Let's see, y equals negative 1 squared plus 2 times 1 minus 1. What does that equal?
2.
Try again.
Negative 1 squared. Wait, where'd you get negative 1?
Because we got 1 squared,
Oh.
and then the negative comes after that. Negative's not part of the square. So we get 0. What does that tell us?
0, 0,
Not 0, 0, 1, 0.
1, 0.
Now, here's the cool part. That saves us a whole lot of work. I don't know what just happened there. Because when we draw our axis of symmetry, and we place our vertex on it, look at that. There's our x-intercept. There's where y equals 0. Okay, we found that back here with our vertex, that y equals 0. So our graph, our parabola, only hits the x-axis at one point. What happened? I don't know, my iPad's going a little crazy here. Okay, hopefully that fixed it. There's our vertex at 1, 0. Now remember, our equation was y equals negative x squared plus 2x minus 1. So instead of going 1, 3, 5, 7, 9, we're going to multiply those by negative 1. And we get negative 1, negative 3, negative 5, negative 7, negative 9. So we'd go over 1, down 1, over 1, down 3, over 1, down 5, and so on. Right? How many places does our graph touch the x-axis? Just 1. See, when our vertex is on the x-axis, It's our only x-intercept. So the y or the x value that we're looking for our solution is 1. And we can check that by plugging it into our original equation.
So it would just be 1.
Yep, x equals 1. Everybody good?
Okay.
All right, now for a super weird one. So we start with x squared plus 7 equals 4x. What's our first step?
Getting them all on the same side.
Subtract the 4x, get them all on the same side. Okay, then what?
Y
We make it y equals.
x squared minus 4x plus 7. Then we have to find the
Gotta find the axis of symmetry, which is x equals.
negative b over 2.
Okay, what's b in this case?
Negative 4.
What's a?
1.
What do we get?
Negative
Try again. Positive 2. Negative. Negative.
2.
Gotta be careful with your signs. So we have x equals 2. So how do we find our vertex? Plug it in. Sounds like a Glade commercial. This math lesson brought to you by Glade, a Johnson & Johnson company.
Watch this video get taken down because of that.
Yeah. All right, so what do we get for y?
Minus 3.
Y equals 3.
Oh, I got that.
Okay, there's our vertex. So our axis of symmetry is 2, our vertex is 2, 3. All right. Yep, iPad's having a weird day. That's what it needs. So we put our axis of symmetry there, x equals 2, and our vertex is 2, 3. Okay, now, our lead coefficient was still 1, so we're going up 1, 3, 5, 7, 9, right? So we go over 1, up 1,
Wait a minute.
over 1, up 3, over 1, up 5. That's going to be off the graph. All right, what's our x-intercept? That's where our solution is, right? Where's it cross the x-axis? It doesn't. Because we have a graph whose vertex is above the x-axis, and it's going up from there. So there is no x-intercept. So you know what that means? No solution. There's no value I could put in for x to make that original equation work. Our answer is no solution. Make sense?
You have to do all that work just to find out that it's not solution.
No, you don't. Because if you thought about it, we see that our vertex is the point 2, 3, right? That's above the x-axis. Now, that's not the problem in and of itself. The problem is that it's above the x-axis and the graph opens up, right? If it had opened down, we would have been okay. But it opens up. So if our vertex is above the x-axis and our a, our lead coefficient, is greater than 0, so it opens up, we have no solution. When else could we have no solution?
When a is greater, when it's 0,
Uh-huh.
below,
When our vertex is below the x-axis
and it opens.
and a is less than 0, it opens down. We'd also have no solution there.
Oh my
Okay.
word, it's mind blowing.
Yes, there you go. Your mind just exploded. Yeah, we're going to have to clean that up.
Someone gets the box.
Does this make sense? Any questions?
Another commercial.
All right,
Sponsored.
let's move on to the homework.